All right, so in this video, I'm going to teach you how to solve limits graphically. So if you want the faster version of how to solve this, go ahead and look at one of my other videos. And now let's go ahead and get started. So when you're looking at your graphs, for the most part, you're really only looking at a couple key things. So, you know, when it says to find the limit, what that is essentially meaning is notice where the line crosses or passes through, I should say, at the given x value. So that might seem straightforward, but there's a couple nuance with this, and it really just comes down to the terminology that they give you. So they're going to give you limit of some sort of function, but they're going to give you like three options. So they will give you limit of f of x as x approaches a minus limit of f of x as x approaches a positive, and then we're also going to have the limit of f of x as x approaches a. So really, all you're doing is you're looking at the signs to the right of the number. So whenever you see a minus, this is a limit from the left-hand side. And whenever you see a positive, that means from the right-hand side. And notice when there is no sign, what that basically means is um, if there's no sign, then it's going to be from both sides. Now, this might not seem very intuitive, but I really, really implore you, when we're doing this, it's a simple, oh, just follow the line from the left, from the right, or from both sides. And if it gives out any sort of number, that's all that you're looking for. So limits do not care about holes or closed points. So if we take a look at this example right over here, and let's say I'm going to ask you, what is the limit as x approaches 5 plus? So let me go ahead and make this a little bit bigger. And while we're doing this, you want to find the number 5. That's going to be your first step. So go ahead and take a look at the number 5 and notice where it passes through. Now, the second step is you're going to take a look at the sign. This plus sign means from the right. Now, when we're doing this, you don't need to start all the way at the end of the function. What I typically do is I will just go one away from 5. So in this case, 6. And I just follow this line until I hit x equals 5. Now we're at this red dot here. And basically, I ask to myself, what is the y value at this specific x value? So in this case, the limit as x approaches 5 from the right side is equal to 7. Because another quintessential thing you want to understand about limits is, limits are y values. That's essentially all that limits are in an algebraic perspective. And that's going to serve you very, very easily for a lot of these graphs. So when we have, let's say, another sort of graph, and let me just go ahead and copy and paste this little cheat sheet because it's going to be super helpful. So when I take a look at this problem, And let's say if I were to ask you, what is limit as x approaches 3 minus of my function? Well, once again, I'm going to find my number 3 and see where the line crosses at that point. Now, notice it has a minus. So minus means from the left side. And if you think about this in a logical perspective, this is actually really helpful. So if you think about 3 minus, not negative 3, if you're approaching the number from the right, you're essentially asking what numbers are smaller than the number 3. That could be 2.99, 2.9, 2.6, 2, 1. You get the picture. What do all of these numbers have in common to the number 3? It's the fact that they're all to the left side of 3. So if you were to imagine, okay, I'm going to plug in the number 2.9, and I'm going to see from 2.9, you know, where does the y value or the line approach as x equals 3? So from the left side, you know, I don't think I did the best idea of this. I'll guesstimate that it's like 6.5 or something. Yeah, we'll say it's like 6.5 or something. So we'll say the limit of f of x as it approaches 3 minus, which is from the left, the y value there is going to be equal to 6.5. Now you might be wondering, okay, well, what about if I take the same exact problem and now I just go ahead and I'm going to ask you to find the limits as x approaches 3, not minus, but plus. Does that change the actual value of the limit? Well, since we're going 3 plus, numbers that are bigger than 3 are 3, 3.5, or 3.3, 3.5. So these are numbers to the right of 3. And you're going to go ahead and follow this line from the right of 3. And notice, where is the y value? There. It is going to be equal to, we'll just say 6.5 again. So the limit from the left-hand side and the limit from the right-hand side are equal to each other. So just know, just because you have a plus or a minus doesn't necessarily change whether or not the limit is going to change as well. Because ultimately, what we are doing is we are just following this line. Wherever the line goes, regardless of other features, that is going to be equal to the limit of the line. Now, that's like the simple cases, and a lot of the problems, they are in fact going to give you extra features in the problem, which are like holes and close points and jumps and skips and all that sort of stuff. So I do need to go over those portions with you. So let's just say I want you to find the limit as x approaches 4 plus, and you'll see what I'm talking about because you'll notice at x equals 4, there's a lot of stuff going on. But remember, limits only care about where the line travels, not the points. So notice that I have an open point at x equals 4 and a close point. So you're going to follow the line 4 plus. If I take this little chart again, and we sort of move some stuff. So you will see that when we have 4 plus, that's the limit from the right-hand side. So where is the y value as the line approaches x equals 4? Well, it looks to be 8. But you might be wondering, well, Rudy, why is the limit equal to 8 when there's an open point? And like I said, limits don't care about where the functions are defined. The way you need to think about the limit is as x approaches. Approaches implies you never go to the actual x value itself. You just get very, very close. And very, very close really just means that line over there. So that's just going to be x equals 8. And, if I were to ask you, what is the limit as x approaches 4 minus f of x? It's going to be the same idea where you go about 1 away from the line, or from 1 away from 4 from the left, and see what y value it approaches. Once again, it's going to be 8. Now, this is where the closed point does matter. So if I give you f of 4, where is the function defined at 4? So I'm asking you exactly at x equals 4, what is the function defined as? Functions are always defined at their whole point, so I can write that down. Functions are always defined at closed points. And in this case, when x is 4, my y value, the function, is actually defined at 5. So limits don't care about the closed points. You can have the open points. You're just following the lines. Now, that's a very, very simple example. And we are going to go over cases where, there's going to be a lot more just information going on into the problems. And that's totally okay. When we have this problem right over here, and I start giving you a lot of information, we're just going to work on this piece by piece. So I'll give you all the cases, and then we'll go through the problems that way. Oops. So at least in this case, we're going to have all these different cases. This will just kind of be on the side. And we just need to look at this graph. So we can say, what is the limit as x approaches 4 plus? So we find 4, which is right over there. We go from the right, slightly to the right of 4, because plus means from the right. The line travels at -1. Now, let's say if I give you the limit as x approaches 4 minus. Same line, but from the left. Now, this one's going to be slightly different because the line goes to this closed point, and I don't know exactly what that point is. It looks to be some sort of decimal. We can just call that -0.9. But you'll see that the line from the left and the line from the right technically go at different y values depending on the side that they're at. Now, let's say if I were to ask you, what is the limit as x approaches 5.5 signless? So signless means there's no sign and we need to approach the limit from both sides. 5.5 is where this red dotted line is. And we need to look, okay, the limit from the left, the limit from the right, do they approach the same side? Or do they approach the same y value? In this case, they do. They both go to the y value of 0. So the limit of f of x as x approaches 5.5 is equal to 0. And that's going to be a case where, it is going to be something that exists. But you will notice that when I give you this problem, the limit as x approaches 0, which is essentially where the y-axis is at. So you need to find out where the line goes from both sides. The limit on the left-hand side, what is the y value that it is approaching? Since it keeps on shooting up very high, we can assume that it goes to positive infinity. The same can be said for the right side. Since it's pointing down very steeply, we can assume that it's actually approaching negative infinity. And since these y values are different, the limit as of f of x as x approaches 0 from both sides, it is going to be does not exist. Because if you want a limit that exists from both sides, they need to be equal to each other. If they're different, automatically they're not going to work. So that is the very, very basic idea of how to solve limits, and I hope you found this helpful.